Hey everybody, tonight we have a problem that's essentially the same as an SMO Senior Review question. Now, by natural number, I just mean the positive integers. Like this. Ad nauseum, I mean ad infinitum. Okay, just the positive integers, that's what I mean by natural number. So we're looking for the smallest natural number m such that the two real numbers that are controlled by this equation have a sum less than that natural number. Okay. Now this completing the square step is fairly natural. It turns out we can use something called Cauchy-Schwarz on this left-hand side. But notice you have a 200 squared in here, and then you have a 200 squared on this side. They cancel each other. All right. And so you literally, if you just look at what happens when you expand this, you get exactly this. The 200 squares just cancel with each other. Okay. So that turns out to be quite useful. Now, Cauchy-Schwarz is, I've struggled with it before and I'm slowly getting used to it. If you think about linear algebra, it just says the inner product of two vectors in component vectors is less or equal to the product of the magnitudes. All right. And it's some people call it Cauchy-Schwarz. I don't know if there's some kind of rift going on here. Cauchy-Schwarz. This guy just called it Cauchy. All right. Now, so what we do is something called the famous one trick. And if this looks confusing, what I did is I took the squared version of things here. All right. So I squared both sides. I squared this, and then I squared this whole thing right here. All right. And that, hopefully I kept things lined up. Now, what seems weird here is this one. This is a famous thing called the one trick in Richard Steele's book. You put the 1, which appears superfluous, but it actually comes up, it's really the a sub 1. Then x minus 200 is b sub 1. See, it says these are real numbers, but it also, you can accept real valued functions. So that once you see that, it's easy to use this. It says real numbers, or a real number can be represented by a real valued expression, right? So everything's cool. And the ones make things kind of nice here because when you simplify things, this is what happens, okay? And again, I'll try not to go into too much detail on all of that. You can see exactly what happened here. But the one trick is really kind of slick. You throw a 1 in there because 1 is the multiplicative identity, right? Okay, now we get x plus y like we want it. And when you add 200 to both sides, this is tantamount to x plus y is less than or equal to 200. See, let's see, that'll be 200 times 1 plus root 2. Like that. Okay, let me get a little more space here. Okay, now y'all, this is the same thing as y'all, I'm going to use, for root 2, I'm going to use the decimal approximation, which is not hard to see since 1.4 squared is 1.96. But this is circa, and this is, I think that the contestants in these competitions have this memorized and they can use it, you know. Okay, it's about like this. And again, not too hard to see because 1.4 squared is 1.96, so it's kind of easy to remember that. All right, now, so this would be less than or equal to 2.414. I wrote that kind of backwards here. Times 200. Sorry, y'all, I put this in it, but anyway, it's no big deal. Remember, multiplication is commutative. It saves me the trouble of having to erase it. But what is that? That's equal to, oh dear, I gotta push it over to the right 2 units, so you would get 482.8 approximately. Hopefully I got that right. Yeah. 2 times all this stuff, and you push the decimal over, right? Okay. But notice we're looking for the m, and this is a wonderful example of the ceiling function, right? We're looking for the value of m, the integer, the smallest integer, not the greatest integer, but the smallest integer. It's the dual to the floor function. But it's, so it'll be 483, but the way you write this using this cool Quine Corner stuff here, 482.8. And again, this is the exact dual of the ceiling function that you see on Michael Pinch channel all the time. So that's equal to 483. And that's the answer to the question, unless I made a mistake on the calculation right here. Okay? So again, the only thing we had to do to avoid the calculator is go with this well-known approximation, which is not hard to believe. You know, again, when you 14 squared is 196 and just the decimals, you know. But anyway, that's it, I think. I don't think I made any mistakes. Let me know what you think. I enjoyed that one. Let's come up here and write down m is equal to 483. Okay, good night.